Hi guys, welcome to another episode of Learn Technology in 5 Minutes by MakerDemy. This is Shubham and I am part of the instructor team at MakerDemy. In this episode, we will learn about LiDAR, how it works, and the applications that LiDAR is best suited for. Do you ever wonder if you could map the area around you? The bridges, the buildings, the hills, and the rivers? If you answered yes, some good news. The LiDAR technology can help you on this. LiDAR stands for Light Detection and Ranging. It is a popular remote sensing method used to measure an object's absolute distance from the Earth's surface. LiDAR was first used in the 1960s by mounting a laser on an aeroplane, but only after a couple of decades, in the 80s, it became a popular method for calculating accurate geospatial measurements. LiDAR follows a simple principle we all know. Throw light at an object on the Earth's surface and calculate the time it takes to return to the source. The laser emits pulses of light to measure the object's variable distance from the LiDAR system. These light pulses, along with the information collected by the systems together, can generate a 3D map about the Earth's surface or just a marked object. As light travels at a very high speed, the process of measuring the exact distance through the LiDAR is incredibly fast. The formula used to arrive at the precise distance of the object is as follows. The object's distance from the light source on the LiDAR is equal to the product of the speed of the light and time of flight, the whole divided by 2. The distance traveled is then converted into elevations. This is done using the LiDAR system's key components, including GPS that identifies the XYZ coordinate locations of light energy, and an inertial measurement unit that provides the plane's orientation in the sky. There are three primary components of the LiDAR instrument: the scanner, the laser, and the GPS receiver. For data collection and analysis, devices such as photo detectors are used. Based on the system's functionality, LiDAR systems are divided into two types: Airborne Lidar and Terrestrial Lidar. The Airborne Lidar is installed on a helicopter or drone for collecting data. The two types of airborne LiDAR are topographic and bathymetric. Topographic LiDAR generally uses a near-infrared laser to map the land, while the bathymetric uses water-penetrating green light to measure seafloor and riverbed elevations. Unlike the airborne LiDAR, the terrestrial LiDAR systems are installed on moving vehicles or tripods on Earth's surface for collecting accurate data points. Systems mounted on a moving vehicle are called mobile LiDAR, while the ones mounted on a tripod are referred to as static LiDAR. Terrestrial LiDARs are most commonly used for observing highways and analyzing infrastructure. So where can the LiDAR be used? LiDAR can be used to accomplish developmental objectives in various fields, from oceanography to digital elevation or terrestrial model and agriculture. In oceanography, when one wants to know the ocean's exact depth to locate any object for research purposes or any maritime accident, LiDAR is used to accomplish this mission. It is also used for calculating phytoplankton fluorescence and biomass in the ocean's surface. Terrain elevations are useful to plan the construction of roads, large buildings and bridges, and so on. LiDAR technology has XYZ coordinates that facilitate the production of 3D representations of elevations. The agriculture sector benefits from the LiDAR technology with applications including the analysis of yield rates, crop scouting, and seed dispersions. Apart from all the applications mentioned, LiDAR is used by geoscientists in the field of geomorphology and also by the military for security operations. In this fast world of technology, LiDAR's role may change and expand into new horizons depending on the need. That is all, folks. If you like this video, smash the subscribe button and ring the bell to be updated about our future video releases.